Okay, so what did we say? We said an exponential equation is any equation that contains the form, and I'll put this y equals what? Any base to what power? I said cx, but it basically, if the variable is in the exponent spot, you have an exponential equation. Now they do say cx, but what they're trying to tell you is something like this. Your base could be back here, 3, raise it to the, what did I do? 2x equals what? Do I have a 10 back there? Yeah, 10. So there is an example of what you will do today, right there. And your job is to figure out x right there. Now, do you guys remember that in the past, I've said, how do you solve these? How did I say, get the answer then? Does guess and check ring a bell? Remember when I said just start guessing, and then if you get close, just keep going. So you just guess. You say 1, 2, 3 until you get to 10. And once you get to 10, you got it. But that's such a slow process. So here's what we're going to do today. We're going to work with this right here, common base. Now, I want to show you a couple of easy ones. Here's an easy one. This is actually so simple that I think you can do it without me doing anything. Tell me what you think the answer is. 3? Okay. 2 to the third is 8. Right. But here's what you're going to do today. You're going to try to take the two bases. 2 to the x equals 8 to the first. You're going to try to take the two bases and make them exactly the same base. So here's what I mean. 2 to the x, I'll leave it. Can you change 8 to a power of 2? Yeah. 2 to the what? Third. Okay. Now this is such an easy problem that I didn't even have to do this, but I want to show you what you're doing. 2 to the x equals 8, or 2 to the x equals 2 to the third, which is 8. Now, when your bases are the same, if you have the same base, then to be equal, what about these two exponents?
That would be the same.
They have to be the same. So all you have to do is set them equal to each other and solve the equation. Oh, x equals 3. You guys knew the answer anyways. So let's try this. How about this one? Let's do it again. How about if I go 2 to the 5x equals 8? Do the same thing. Change 8 to base 2. If you change 8 to base 2, you'll get 2 to the what?
Third.
Third is 8. Well, for this to happen, bases have to be the same. Exponents have to be the same to be equal. So then you just set these two numbers equal to each other. Whoa, why did I write that? Sorry. 5x equals 3. So your solution is what?
3/5.
3/5. Okay, we got it. So when I say solve this equation, you say 2 to the 5 times 3/5 should equal what? Should equal 8. That's what you're doing. If the bases are the same, it's such an easy problem. So your job will be make them the same if they're not. Now I found out yesterday after helping them all and Maddie, you guys can't even read your notes. Your notes are really blurry. Probably because this was blurry. Who knows? So what I'm doing right now, I'm going to go like this. Just make them all bigger. So just be patient. Okay, there you go. So that you can read them. Okay. Which one's... Okay. All right. Now, let me come down here. All right, so that takes care of that. Okay, go up here. Let's start solving a couple of these. Ready? Go D down. Here's B. B can go there. Going down. B is going to go here. Come on, B. Up, C. Okay, good enough. Okay, 5 to the x equals 125. Well, this one is way too easy. But the way I'd like you to solve all of these is try to get the bases the same. This is base 5, this is base 125. Well, 125 can turn into what? 5 to the third equals 5 to the x. Once you get the bases the same, you know the exponents have to be equal. So set them equal and solve. Well, there was no solving to do, it's just 3. And I think you knew that to start with. 5 to the third equals 125, right? Okay, now you have to change the bases. Either you make them both base 6 and base 6, or base 216 and base 216. You do not want to make them 216. That would be way too tough. So 6 to the 2x equals, can you change 216 to base 6? 6 to the what? Yeah, 6 to the first is 6. 6 squared is 36. 6 cubed is 216. Once you get the bases the same, set the exponents equal to each other. Answer? 3/2, right? Can you check these? Yeah, I mean, you could just go like this. What is 2 times 3/2? 2 times 3/2. I thought that'd be quick for you. 2 times 3 is 6, divided by 2 is 3. 6 cubed is 216. It works. So, guys, you can check these answers. All right? 3, raise it to the 2x plus 5 equals 27. What's x have to be for this to work? Well, let's change our bases to what? Yeah, it's so easy to go 3 and 3, because what is 27? 3 to the third is 27. Here you just have 2x plus 5, right? All right, bases are the same. Exponents have to be the same, so set them equal. Subtract 5, 2x equals what? 22. What am I doing?
Isn't that supposed to be 3?
Yeah, that's supposed to be 3. Sorry. It's supposed to be 3. Now when you subtract 5, you get what? -2. Divide by 2. You get what? -1. Good? Okay, look at the next one. Oh, I think I skipped C, didn't I? All right, go to C. If you look at C, I see base 7, and I see 149th. Now, 149th is the base. Can you turn 149th into 7 to some power? Is this possible? Yeah? 7 to what power is 1 over 49? -2. Hey guys, 7 squared is 49, so 7 to the -2 is 1 over 49. So yeah, it's -2. And I still say this is the hardest part. The hardest part is getting that base to become base 7. That's the hardest part. Set the 2 exponents equal to each other. Answer? What'd you get? What? -1/2? Okay. Got it. A, B, C are done, right? Hardest one is coming. It's what? E or whatever. Yeah, E. 2 to the, I'm going to do it on a different page. 2 to the 2x plus 5 equals what? Okay, 8 to the x minus 7. All right, what base do we want to make? Base 2. Okay, so 2 to the 2x plus 5 is done. This becomes what? 8 is 2 cubed. Okay, but now wait a minute. This is just the number 8, just like that's the number 8. This 8 was raised to the x minus 7 power. Your 2 cubed, which is 8, is still going to be raised to the what? X minus 7 power. Now your memory has to go back to chapter 6. What's your memory on something like this? When you take a power and you raise it to a power, what do? You multiply. It's x to the what? 10th. And if that's what you do, that's what you do here. So you're going to get 2 to the, raise a power, take a power, raise it to another power. 3x what? Minus 21. 2 to the 2x plus 5, right? Hey, your bases are the same. Your exponents have to be the same for it to be equal. So, come on over. Take this, set them equal to each other. 2x plus 5 equals 3x minus 21. Start solving. What do? What's the first thing you want to do? Subtract what? Okay, 2x take away 2x, gone. 3x take away 2x, x minus 21 equals 5. Add 21, right? If you add 21, right? Is anybody checking these answers? Guys, you know if you check your answers, they better work, right? Hey, you need to check this. Let's just try this. Ready? If you put a 26 here, what's 2 times 26 plus 5? What is that? 2 times 26 is 52 plus 5? 57. 2 to the 57th should equal 8 to the 26. Take away 7 is what? 19. For that answer to be right, this has to be true. 2 to the 57th should equal 8 to the 19th. And you know what? These numbers are so large, it goes into scientific notation. If you actually did it, it would be some number times 10 to the 17th power. And then if you do this one, you'll get the same number times 10 to the 17th power. So it works. Just check them. Because I don't know why you would trust these answers. You could do so much wrong here. I mean, you could mess up one little piece. You say the answer is 26 and it was 18 or something, you know? Okay. So what's the goal when it comes to exponential equations? Make the bases the same. If you can make the bases the same, it is probably the easiest problem I'm going to give you on the test. Okay? Any questions? So if that's supposed to be the easiest problem on the test, what are you going to do when you run into, I already passed it, I think. Oh, it's on the bottom, isn't it? Ah. Okay, it's on the bottom. What are you going to do when you can't make the bases the same, such as these, okay? Hang on. Okay. Again, you can't read them, so let me get these bigger. What you guys can't read is you can't read the exponents, I don't think, can you? Okay, here we go. This. Okay, so there you go. There's a problem here, and the problem is this. I got base 5, I got base 130. Can you make 130 base 5? 5 cubed is what? Okay, and 5 to the 4th is what? 625. I missed it. I can't do it. Guys, your method of making both bases the same is out. You can't do it. So now your method doesn't work. So what are we going to do? I'm going to turn the lights on and wake a couple of you up. Because some of you guys aren't even paying attention. Stay with me, buddy. All right, you guys ready? See this? You can't make the bases the same. So here's what you're going to do. You're coming over here and you're going to start to realize what you've been doing. Exponential equations, Bryce. If you graph them, y equals 2 to the x looks like this. You did this on your quiz on Wednesday. Y equals log base 2. Here's base 2. Here's base 2 of x equals, looks like this. Look at these two functions and look at the points. This point is 0, 2. No, it is not. Sorry, it's not 0, 2. It's 0, 0, 1. This point is 1, 0. This point is 1, 2. This point is 2, 1. This point is 2, 4. This point is 4, 2. You guys noticing about the ordered pairs? They're what? They're flipped around. You guys remember when I said flip the variables? What were we doing? Yeah, we were trying to find the inverse. So guess what? Exponential equations and log equations are what? Inverses of each other. They're inverses. So what does that mean to you? It helps you solve a problem. The problem here is 5 to the what? 2x. This is exponential. So if you want to get rid of exponential equations, you take the log of both sides. So here's how you're going to attack this problem. You're going to go like this. You're going to say log of 5 to the 2x equals log of 130. So this is why it helps you to know that these two are inverses of each other. If you see exponential, why don't you just take the log of both sides? Guess what I'm going to say on Monday? On Monday, I'll say, if you see a log equation, do what? Yeah, it's not called take the exponential, it's called convert it. Convert it back to exponential. It just goes back and forth. Okay, well, look at what you have. There is a property from yesterday that will help you solve this problem. Brady, you read the lesson?
Yeah.
What's the property? What do I do?
What do you mean?
What should I do from here? There's a property that's going to help me.
I'm confused, I guess.
Okay. Remember the property that says if you take the log of a number raised to a power, where can the power go?
Oh, behind, yeah.
Well, I was hoping you'd say in front. So it becomes...
Behind, that's what I think of.
Okay.
I think 5 is in front, in my opinion, because I read left to right.
All right. 2x goes in front times the log of what? 5 equals log of what? 130. So this first step I did, I used your property from yesterday to take the exponent and put it out in front. But now the next thing I'm going to do is solve it for what letter? X. So here's your x right here. You want to solve for x? Well, you have a couple things in your way. One of them is multiplication, multiplied by log of 5, and one of them is multiplying by 2.
Divide by log of 5.
Okay.
No, I mean like divide.
Well, that's my
Oh, yeah, you do.
division bar. Log of 5 divided by log of 5. Could I speed this up and also do what? Can I also divide by 2? Okay. So what I'm dividing by is 2 times log of 5. There. That's out. That's out. That's out. You get x equals. Well, what do you divide 1 log of 130 by? 2. Right here.
Log of 5.
Times log of 5. Now, if you want to be really careful with your calculator, you'll get this, and here's how you do it. Tell your calculator, I want that answer on top, divided by that answer on the bottom. So use your grouping symbols. You okay with this? Try it. I know the answer. I want you to say it.
How many decimals?
Oh, I'm sorry. How many decimals? It says right here. Nearest what? 10,000. Well, remember, the first number after the decimal is tenths, hundredths, thousands, 10,000s. 4.
6, 5, 7,
How come I don't remember 6.5?
Yeah, I got 1.512.
Yeah,
2.
5.1. 2? You got a 2?
I got 5.122.
2.2. Haley, you got a 1.6, huh? Did you type it in just like I typed it in? Parentheses, and you did all that? You put 2 times log of 5?
I can check it in again.
Try it one more time. Okay. Hey guys, how do you know it's right? Plug it in. You know what? Maybe just once we should try it. 5 to the 2 times 1.522 is it 130? Try it. Hey, I get these answers when I solve exponential equations. I never trust them because the answers look so terrible. The answer is 1.512. They look terrible. I just check it quick. So has anybody punched in yet? What'd you get in?
130.00.
Yeah, we got it. 130.00, yeah. Pretty close. Okay, guess what? They're all the same. So you know what I want you to do? Finish it, go. It's the same thing every time. I'm gonna trail you by a minute. Just 1 minute, okay? Yeah, what happened?
So I typed it in again.
I'll pretty. Oh, because you used the parentheses. And then you didn't use one.
That's pretty good.
So this parentheses is not hooked until you get to the next one. This one, right there. So you're hooking that one in front with the one in the back. So what I would do is guess. I would just tell it, give me log of what? And then
I wonder what the
wrap
speed
the one
is by
thing
itself.
and then wrap it again.
It's like 5.
You did not.
Yeah, or 10.
I just divided by
So if you
then you don't.
Okay.
So what was going on with yours? You just didn't put double parentheses.
Yeah.
You actually.
that's 4 yards.
Well, I didn't put on there. I put 2.
It's like
I
taking,
put
it's like taking big steps.
Oh, you know what you're doing then? You're dividing by 2. You're not dividing by 2 times log of 5. Okay. All right, your minute's up. I'm going to catch up to you. Here I go. 7 to the 4x. I cannot make it both base 7, so now I'm stuck. I got to do the log of both sides. Log of 7 to the 4x equals log of 800. From yesterday, I'll use my property. I'll take my power, 4x. I'll put it in front. 4 times x times log of 7 equals log of 800. Oh, you know what I forgot to tell you? Why can we use a calculator? I'm in base 10. I'm taking base 10 to both sides. If you take base 10 like we're doing, you can always use your calculator. All right.
What if your calculator has like a base anything button?
It doesn't really?
Yeah.
Yeah, then you could do it. You could do any base, but Brady, don't do that. That's more work.
Well, I mean,
Yeah, it's just more work. You can do it. If you want to do base 5, you can, but don't. It's just more work. Use your log button. I mean the log button that just says log. So what are you going to divide by? What would you guys divide by to get rid of all this stuff? 4 log 7. 4 log 7. Now 4s would cancel. Log 7 would cancel. You'd have x roughly equal to 8.5 what? 8.588. Okay. 0.8588. Yes? Everybody getting it? Again, if you're going to sit there and do nothing, then you won't get anything out of this. You got to try it. Otherwise, I don't know how to get this through to you. All right. I don't know if you're already on C or not. Was there anything wrong with C? Remember when you start a problem, it's got to look like this? It's got to be b to the cx. It's got to be a base raised to the cx equals some number y. You have a base raised to the x, but then you have something in the way. You got the add 3 in your way. You want to get rid of add 3. So the first thing in this one, you actually should have just said, knock out the 3, 5 to the x equals what? There. Now this looks like the previous two problems, right? Okay, once you get to this point, guys, you're ready to go. Just take the log of both sides and start. This one's not a bad one because when you take log of 5 to the x, where's the x go?
Me? She graduated. Right. Congrats, Brad.
Yes? No? Okay, Bryce? Bryce? Get me with me? Okay. X goes in front. Get rid of log of 5 by what? Division. Okay, log of 5. Divided by log of 5 cancels out. What's log of 214 divided by log of 5? 3.33 what?
3.33.
Oh, 1/4? Okay. 3.3314. And again, I never trust these answers. So I plug it in, just type it back in and make sure when I take 3 plus 5 to the 3.3314 power, do I actually get 217? I do it. Especially on a quiz, especially on a test. I don't sit there and go, oh, I trust this answer. Which is really close, right? Last one. Is this one ready to go? Do you have a base raised to a power of x? Yes, you do. You have it. Okay. So you're ready to go, I hope. Log of. Good? Yeah, that's pretty easy. Now, what do you do with the power? 3x plus 1. Move it out in front. Just move the power out in front. That's what the property said yesterday. So take this number, whatever 3x plus 1 is, whatever that is. By the way, that is just a number. It could be 5, it could be 10, it could be 20. That number times log of 7 equals log of 20 what? 8. Now remember, you're solving for x, but x is wrapped up inside here. It's like tightly wound inside the grouping. So what do you do first? Divide by log of 7. Just 7, log of 7, right? Because that would just knock this out. All that would be left is what? This number, 3x plus 1. Hey, is anybody tempted to do this? Are you guys tempted to go 28 divided by 7? The answer is 4. Is anybody tempted to do that? Because you know what? Students will do that. Students will take 28 divided by 7, they'll write 4. It is not 28. It's the log of 28 divided by the log of 7. Don't do that because some of you are probably going to look at that and do it. Okay, what is it?
1.7.
Okay, 2, 4. Okay. Now Jessica's been telling me the answer, and I guess I haven't been asking you. Are you guys agreeing with her?
Yeah.
Yeah? Okay. All right. Now we're down to 3 times x plus 1 must equal 1.7 and 125. What do you do first? Minus 1. Divide by 3, and you'll get there. Okay, and you get 0.7124 after dividing by 3. Two, three, what? 0.2375. Go up to the top of the problem and go, just punch it all in. See if it actually works. I mean, guys, this needs to be done. You will get the weirdest answers to these problems. It's always like a decimal that goes on forever. You cut it off. Don't trust it because you can do this wrong. Are you okay? So how are we going to get rid of exponential functions that we can't change the base to be the same? We're going to do what to both sides? Take the log of both sides, move the exponent up in front, and then just start solving. Yes. Yeah. Either you make the bases the same, which I did the first 4 times, or you take the log of both sides. That's it. Okay, I got one story problem for you. Turn the page. You read it. See if you can set up an equation. I mean, that's half the battle, or better. Hint, hint, this is an exponential chapter. Are the trees growing or are the trees decaying? They're what? How come?
You're cutting them. They're trees.
You're cutting the trees, you're actually, the word was? The word was what?
Harvest.
Harvest. You're going to harvest the trees, you're going to take them off the land, and you're going to use them up. It's decay. It's not growth. This is an exponential chapter. You have to think exponential decay or exponential growth, and you're saying what? Decay. Okay, so decay would have been whatever you start with, A times what? Minus. Yeah, you're giving me the numbers, but the formula said A times 1 minus R, the decay rate. For how many years does this happen? T years should equal what? Whatever we're talking about. What are we talking about? Are we talking about money? No. Trees. Okay. So can we just say trees? Number of trees. All right. Trees equal that times 1 minus R to the T. Okay. What will we start with? How many trees do I have? 1,200,000 trees. Okay. Okay. And then times 1 minus the harvest rate. We're taking away what? 5%. How many years? So we don't know the years, that'd be T. How many years will it take to harvest half the trees? There's what you started with. What's over here? Half. Half the trees are going to disappear. What's this number going to go to? How much? 600,000, yes, there you go. So your 1.2 million trees is now down to 600,000 trees. How many years will that take? Okay, help me, what's this? 1 minus 0.05. 0.95, got it. Equals this. But wait a second. I thought we said we have to have this look. B to the CX. B to the CX. Well, here's your B. Here's your X. This is your variable. The C is right here. It's 1. 1T. We got to get rid of this number. 12. Not 12. We got to get rid of this number. 1.2 million. Yeah, it's multiplication. We would just divide, wouldn't we? By 1,200,000. And then over here, divide by 1,200,000. What do you get? You should get a half. You cut that number in half, you're getting a half. Oh, okay. You do realize this. You're staring at the same problem. You just did it 4 times on the previous page. What do you do to solve for t? Take the log of 0.5. Take the log of 0.95 to the t. Finish it up, please, if you can. So did you move your T out in front? Or if it's Brady talking, out and back, right? Okay. Then you did what? After this, you did what to solve for T? Log of 0.95. Gone. T. Divide log of 0.5 by log of 0.95. Is it exactly 0.5?
It's like 0.5.
Oh, okay. So I better put that. Okay. So you're saying 0.5 and you're rounding that answer? Okay. So that's a rough estimate. This many what? Roughly 13.5 meters. Okay? All right.
No. You're giving me 5 still.
Have a good weekend. Have a good time at prom. Stay safe, make good decisions. And Bryce, hopefully you heard me. Okay. All right.